This video is going to go through section 7.6 in our book, which is all about solving radical equations. So I tried to pick a variety and give you some things that will look a lot like what you'll be tested over when it comes to solving. And this is any radical. It can be square roots, cube roots, fourth, fifth roots, in addition to things written in exponent form like 1/2 power or 3/2 power, something like that. So first one, when you have multiple radicals, you want to make sure that they are on separate sides. So the first thing I want to do with this is I want to add the 2 radical x to the other side. So we have the square root of 2x plus 10 that's going to stay on the left, and the 2 square root of x that's on the right. Now to get rid of a square root, we're going to square both sides. So we'll square this side and we'll square this side. When we square a square root, it cancels. We end up with what was underneath. Now be careful when you work on the right side. When you square the 2, you do get 4. You can't forget about the coefficient. And then when you square the square root of x, you get x. And you should be left with a basic equation. This is just a linear equation, so I'm going to get all the x's on one side, so subtract 2x. So I get 10 equals 2x, and then divide by 2. You get x to be 5. Now, one thing we talked about at the end of this section is you really want to take a moment, even if you don't write anything down, to make sure that your answer isn't what was called extraneous, meaning an answer that you do everything right, but you get an answer that won't work, that's going to create imaginary, that's going to create an improper statement. So when I put 5 in here, I get 10 plus 10, I get the square root of 20. Minus 2 square root of 5, and I have to see if that equals 0. You could either check that on your calculator, or you could do a quick simplifying. 20 breaks down into 4 times 5, so when you bring out the square root of 4, which is 2, you get 2 radical 5 minus 2 radical 5, and that does equal 0. So this is a true solution. For the next one, we want to isolate the radical, so the first thing I'm going to do is subtract 4 from both sides. So I have negative 2 times the cube root of 2x minus 1 equals negative 4. Then I want to divide both sides by negative 2. So I get the cube root of 2x minus 1 equals 2. Then I want to cube both sides. So I get 2x minus 1 equals 8. Then add 1. So 2x equals 9. And divide by 2. We get x to be 9/2 or 4.5. Again, if you go back to the beginning and double check to make sure your answer works out, if you put 9/2 in for x, you'll have 9/2 times 2, which is just 9. 9 minus 1 is 8. The cube root of 8 is 2. So you'll have negative 2 times 2 plus 4 equals 0. That's negative 4 plus 4 equals 0. And that is a true statement. So again, 9/2, or if you want to write it as a decimal, 4.5 is a solution. These two are slightly more challenging. They were ones that we kind of finished the lesson with. We also have to start off by squaring both sides. But the piece that you want to remember, when you square x plus 2, you don't just square individual terms. You have to square the entire binomial. So when you do that, you have to either write it twice and FOIL it, or square double square. So square, we get x squared plus 4x plus 4. On this side, we get 8x plus 1. When you are solving a quadratic, you want to get it in standard form, so we'll get everything on one side. So subtract 8x and subtract 1, subtract 8x, subtract 1. So we get 0 equals x squared minus 4x plus 3. Factor. This one is a minus minus. You get x minus 1, x minus 3. So I get answers of 1 and 3. You need to check both of them. So if I put 1 in on the left, I end up with the square root of 9, which is 3. And I put 1 on the right, I get 3, so 1 is fine. When I put 3 in, I get 3 times 8 is 24, plus 1 is 25. The square root of 25 is 5. When I put 3 on the right, I get 5. So I have 2 solutions. Both of them are fine. And the last one, this is another situation where we have multiple square roots. However, we can never get just a square root on each side. We always are going to have this extra piece. So this one's going to look a little differently. I'm going to start off the same way I started off the last one. I'm going to square both sides. So I get x plus 5. On the right, again, I have to do the square double square. So I square the first. 5 squared is 25. Multiply these together and double it. I end up with negative 10 square root of x. And then the square root of x square root of x is just x. I'm going to subtract x from both sides, and those will cancel. So I have 5 equals 25 minus 10 square root of x. So I still have a radical in here, so I'm still going to go through the process of trying to isolate. So I'm going to subtract 25 from both sides. So I get negative 20 equals negative 10 square root of x. Square root of x. Divide both sides by negative 10. We get 2 equals the square root of x. Square both sides. we get 4 equals x. And again, make sure that your answer is not extraneous. When I put 4 in, on this side, I get the square root of 9, which is 3. When I put 4 on the other side, I get 5 minus the square root of 4, which is 5 minus 2, which is 3. So again, no issues here. Now, just because all 4 of them here didn't have an extraneous doesn't mean you shouldn't keep checking. You want to make sure, especially when you're working with square roots and negative numbers, that tends to create a lot of extraneous solutions. So that is something that you want to look for. Other than that, if you can go through and solve all of these pretty fluidly, then you should have no problem with the solving radical problems on the test.